And we can have faster speeds. The cars, since they're being controlled by computers, can drive at 70, 80, 90, 100 miles an hour, and we won't have any congestion, so you'll avoid all the delays caused by congestion. Safety, 42,000 people a year die in auto accidents. It's a terrible tragedy. We get 4 million vehicle or passenger miles of travel out of that, so it's a very small number per passenger mile, but driverless vehicles will reduce that by at least 75% or more. And they'll be more energy efficient and less polluting than high-speed rail or any other collective form of transportation. Now, in 1939, radar was a state secret. Laser beams hadn't been invented. And Norman Bell Geddes didn't really know how driverless cars would work. But he guessed that they might put some kind of device in the road, like a wire, or in this case, a little magnet, and the cars would sense the magnets and would follow the magnets. The magnets wouldn't pull the car. They would just be something to guide the car. And in the 1990s, the US government started doing research on this, and they developed a very similar program. They put magnets in roads spaced about 3 feet apart, and in 1997 they had a test on a freeway, a new freeway in San Diego. They ran 8 cars at 65 miles an hour, 1 car length apart, which is about 8,000 vehicles per hour if they were running 1 car length apart. And the cars could pass each other, the cars could slow down, speed up, and they worked perfectly fine. At that demonstration, the Deputy Secretary of Transportation said, "Good job, I'm canceling the program. I never want to hear about this again." Now, the reason why he gave is the reason John Caldera will give you. He says, "I get too much testosterone from driving a car and I don't want to give that up." But really, his previous job was general manager of the nation's largest transit agency. And I think he could see the handwriting on the wall. Once we have driverless cars, and you can travel in your driverless car for 24 cents a passenger mile, you won't need to have public transit costing 85 cents a passenger mile, which is what it costs today, or more, taking you around. So public transit will be virtually obsolete, made obsolete by driverless cars. Well, since 1997, most of the research has been done as a result of the Defense Advanced Research Projects Administration, or DARPA. In 2005, DARPA had what they called the DARPA Challenge, where they said, we invite people to provide cars that can drive themselves through a course on the desert. We designate the course. We won't let you know what it is until you get the car there. And if you can successfully drive it and you do it faster than anybody else, we'll give you $2 million. And the winner of that challenge was this Volkswagen. It was designed by Stanford University and Volkswagen Research Laboratories. Interestingly, all the researchers at Stanford University who were in on the design speak German. But it was supposedly the Stanford, it was called Stanley. Actually, it was this car. And then they had what they called the DARPA Urban Challenge in 2007, where they said, we're going to create an urban environment. We're going to have pedestrians, we're going to have stop signs, we're going to have stoplights, we're going to have parking lots, we're going to have other cars, and we're going to give you a course that you have to drive your car through, the first one who gets done gets $2 million. And the Stanley Jr. got $1 million. They came in second. First place was the Carnegie Mellon entry, which was also supported by General Motors. Now, it turns out almost all the technology they were using had been developed by 1997 as a part of the initial research. So it wasn't new technology. The vice president of research for General Motors said, by 2018, you will be able to buy a driverless car. And the main obstacles are not technical, but institutional and bureaucratic. To start it with, if you have a driverless car, you can't use it. It's illegal to take your hands off the wheel of the car. So here's a car that you can buy today. It's a Honda, but the Prius, there are all kinds of cars that do this. They have what's called adaptive cruise control. The car senses cars in front and keeps a fixed distance behind that car. And so you don't have to accelerate, you don't have to brake. The car also has something called lane keep. The car senses the stripes on the road and it'll steer for you. He doesn't have to put his hands on the wheel, except for by law he does have to. And so They have an alarm that goes off if you take your hands off the wheel, but the car is doing the steering, is doing the braking, is doing the acceleration. And there's also another technology called collision avoidance. The car senses all the other cars that are around you in traffic. And if a car decides to pull into your lane right in front of you or right behind you and a collision would happen, your car will brake or accelerate to avoid that. You can buy that in a high-end Prius or a high-end Lexus or Mercedes, but you can also get in a Prius. The cheapest car I know that has these technologies is about $33,000 list price.